Hey, how's it going, Gemma? Let me put up my thing here. Hey, by the way. How you doing today, Gemma? Hopefully you're doing really good today. There you go. Did you have a good day today, Gemma? Good, wonderful, wonderful. Excellent, excellent. We've had a nice weekend already. We got hopefully a better week planned. It's already fun and exciting. See, you're in my chat, and I can't really argue with that. See, it's already fun. Can you send me a DM or something? Sure. You need to send me a DM or something. You can send it to me Discord, right? I think you're on my Discord already. I think. So if you wanna send it to the Discord, you can. What? Ooh, got a few people in here. Very nice, very nice. Can you believe it? Yeah, my Discord perfect. All right. Wasn't sure if you were added. I thought you were, but now I know you are for sure. Hey, Susan. Good evening to you. How you doing? How was your weekend? I hope it was good. I hope you had a fun time this weekend. We got important announcement here. Yeah, pretty good, pretty chill. I was got the announcement here in regards to the final exam. You probably already got the email regarding that, but yeah, I'll probably, obviously, just a friendly reminder announcement, I suppose, is probably the best way I could put it. So hopefully you're getting prepared here for the final exam. So final exams. I tell you, final exams are gonna be, it's like what, 3 more weeks to go. So, exams. Wait, yeah, wait, no, not 3 more weeks. Wait. What's this? Oh yeah, 16 more days, I should say. 16 more days, not 3 weeks. 3 weeks would be 21 days. But no, there's 16 more days until the final is due. Hopefully you've been doing the work. I know you, Susan, I know you do the work. So I know you put in the time and the effort there. Hopefully you've been getting that last test done and dusted out of the way. That's due on the 9th. And then work on everything else. I don't know, but just asking. Oh. Ooh. Ooh, is that so? I'm not going to. Of course not. Of course not. Oh, I'm so excited though. I'm so excited. Okay, I'm super excited. Okay. I'm gonna, you know, I'm doing this. Just doing this. All right? See this? Doing this. I'm super excited. I'm I know what it said. But we're just we're gonna table that a little bit to the side and have a good fresh bit of optimism. So a good fresh bit of optimism is good. We're gonna go with that. Have that little bit of fresh bit of optimism and you know, positive vibes. Positive vibes, Gemma. Positive vibes. That's what we're here to do. Positive vibes. Yay, yay, yay. That's right. That's right. That's correct. I totally agree with this sentiment. 100%. I'm making sure we keep the vibes going. We make sure that cross our fingers and toes and uh, legs and knees and um, elbows. Elbows are kind of hard to cross a little bit. Hang on. Ah, that's really hard. But I'll cross that too if I can. I could do the well. No, see if I cross it like this, then it's like saying an X or like like Chadwick Boseman in the late Chadwick Boseman in Black Panther, or Wakanda. Ooh, yes, please do, please do, please do. Let me know. You know I'm pulling for you. You know I'm pulling for you, 100%. 100%. 10 billion% true. I sent you a Gemma. I sent you a friend request on Discord if you want to accept it or not. I don't know if you want to, but just send a friend request. It's nice. So that's okay, Gemma. Don't worry about it. You're good. You're good. I gotta do some intros, right? Is it that time? It's almost that time. Might be that time. Ooh. Okay, no problem. Take your time, Gemma. Not a big deal. Just a friendly request. That's all. All right, let me do some intros here at the very least, and we'll get going here. And don't matter how many people we got it. All right, let's do this. Okay, let's get started today. Welcome back to Monday. Hope a nice weekend. All right, so for today, it's at least student wise, it's just at this point here, it's you and me, Susan, as far as I'm aware of. Unless there's someone else in there that I'm not sure of, but that's okay. It's the next day. Actually, that's true. It is 12:01 over there. In any case, I want to thank everybody here for coming on back here to the stream. Very good. Just as a friendly announcement here to the students in my class, I have posted the final exam. All right, and the final exam is again going to be. I put it details there regarding the final exam. You should have gotten emails in regards to that. There are 55 questions on the final exam. I made it 12 hours long. I tried to pare it down as best as possible. I had 90 questions of which to select from the pool of questions from our 3 exams that we had in class, and I could narrow it down by 35 questions, and then I couldn't really pare it down any further. So I tried to think of 5 other questions I wanted to get rid of, and then I didn't. I couldn't really think of one to make a good comprehensive exam. So 55 questions I know is a little bit longer than probably what was advertised, but hopefully with 12 hours and a save for later, again, you get 3 attempts for this exam, so a little bit more stringent. But all the questions are from the pool of questions from the first 3 exams. So again, that's why all the practice tests are open for you to go ahead and use. all the questions will be coming directly from the exams, just maybe not, obviously not the same numbers. And that's essentially how it worked. That'll be due on the 19th of May at 11:59, along with the homework. That's the very last day of class. Also, don't forget that the third exam will be due on the 9th of May. That's in 6 days' time. So be sure to finish that up by then. That would be wonderful. So be sure to finish it up by the 9th of May. I would really highly appreciate that. All right, so for the I only have to add 30. Now, 55 is a final exam here, Gemma. So, to be fair, it's a comprehensive final exam. That's why it's kind of, in terms of the amount of questions, why it's longer than a normal exam. Typically, I gave 30 question exams, but for a final exam of 55 to be as comprehensive as possible is what I sought to be fair. But, like I said, I put the whole pool of questions as from the previous 3 exams, so you can practice as much as you like on the previous 3 exams, and then I pulled 55 out of those 90 questions. So if you go over each one of those questions and then try the test, you get 3 chances to do the best on the final. You get a pretty good score. So I think it's a fair system. I think because it's exactly questions you've seen before, it should be exactly what you've seen before from the from things. So there you go. And try to keep it as fair as possible despite the length of the question, the amount of questions. So I don't make sure that it doesn't not only intimidate you. So yeah, I know even for a final you may have 30 questions, but for me, I wanted to cover as much as I possibly can here. And some questions, admittingly, again, I'm giving 12 hours of which to finish. So think of it this way, Gemma. You could have like 30 questions, but only be given like an hour and a half to finish, which is a very short amount of time. Or I can give you 12 hours and 25 more questions, which is basically like 10, 8, 9 times the amount of time. So 8 times the amount of time. So I think that's a lot more fair if I gave you 8 times the amount of time, but only give you another 25 more questions. So a little less than double. And you can come back the next day and finish it if you like. You don't have to finish it all in one sitting. There's another advantage. So you do some problems there, then you save it for later, then come back and do the problems that you haven't tried. You can't obviously go back and do the ones you already did, but I think that's a fair system nonetheless. And you get three attempts to get the best score possible. I think that's okay. See, that's fine. Natty, good evening. I mean, evening/afternoon, whichever way you want to call it. I hope you're doing well if you were listening to that announcement. So there you go. Oh no, I know. This is the exam I get to make up here, but exams are a little bit different from professor to professor. So it's not completely standardized, at least in terms of college. I get to make up the final exam unless I'm directed by the department, in which case then I have to use their exam. So, but they give me a little bit of free reign here to make up the exam as I see fit, to comprehensively cover the course. So that is what I'm doing there. In that case, anyway. Um, so that's essentially what's going on. If you guys have any questions, by the way, if there are any questions that any of you have, guys, feel free to ask me whatever you like. I'll turn on the music again. But you guys can ask me whatever questions that you want to hear at the end of the day. I don't mind. So feel free. I would take the 3 attempts on each exam. Yeah, that's fair. I mean, if you don't do well the first go around, then hopefully you improve the score on the second go around. If that doesn't, if you want it a little bit better, you got the third go around to go do it. So yeah, definitely 3 attempts. I think will be plenty of attempts. That's okay, Gemma. You're always welcome to say whatever you like. It's not a problem. All right, Hade has a question. 10-3, question 6, part B, and... Oh, ignore the and. Okay. Okay. Ignore the and. Just remember what we said here. All right, let's go. to the big board. Let's take a look at the question here. Alrighty. So let's go to the homework here. 10-3, number 6. No. Alright, here we go. Okay. 12-2, question 3. Okay, you don't have to feel bad, Gemma. You're always a welcome part of this chat. You're always a welcome part of this chat, 100%. All right, so calcium is essential to tree growth and promotes formation of wood and maintains cell walls. In 1990, concentration of calcium precipitation in certain areas was 0.15 milligrams per liter. A random sample of 10 precipitation dates in 2007 results in the following data table. Okay, so they do give us a data table here. All right, so here's our table full of values. All right, fine. We'll come back to that in a second. State the hypothesis for determining if the mean concentration of calcium precipitation has changed since 1990. Okay, so the first thing that we have to do here is, Natty, I'm going to get to your question after this one. First of all, we're talking about the concentration in a certain area here. So what we're talking about is the mean here. Just check that data table again, and it is. Okay, Gemma, you have yourself a wonderful day. A wonderful night, I should say. Take care of yourself, all right? Crossing lots of things, okay? Promise you. So we're going to have the mean here be equal to 0.15, all right? So that's our first thing that we have there. All right, and we're given the fact that... We're given here that the mean is not equal to 0.15 milligrams. Remember, it is changed since 1990, so we're going to check that, and we got that. Perfect. Okay, so in this case here, we have to construct a 98% confidence interval about the sample mean concentration of the calcium precipitation. Okay, let's go ahead and do that here together. All right. Now for this one here, we're going to need the calculator for this guy. So let's bust out the calculator for part B, and then hopefully we can maneuver from there. Because I believe this is the one that you wanted to acknowledge here, Heide. Okay. So first and foremost here, we are going to need, of course, the data table in this case. So we're going to need to copy down these numbers. Now, Heide, to be again, your numbers are going to be different than possibly the ones I have on stream. So of course, you'll use your numbers here appropriately. But we'll just enter this into a list. Let me clear out my old lists, and again, highlight, clear, and enter. We'll go ahead and put in the new list of data here given to us by the problem. All right, so I got all 10 of my values in here in my list. Perfect, sounds good to me. All right, so let me quit out of this here. We'll hit second in mode to quit out. All right, so what we want to do here first is we're going to need to go ahead and take a look here at our 98% confidence interval. So let's see how we can do that here. And let me reference something here real quick. Something here. You go. Now there's reference back to our guys here. All right. So just going back here for just a second, we can use just as a friendly reminder here. That's where we did chi-squared. I don't remember. I need. No, that was 10-4. Right, that's what we needed to do. Okay. So for this one here, specifically, Heide, we're gonna need to go ahead and use, not this, why do I have this up? We're gonna go to second, and we're gonna go to, no, we're gonna not second, sorry. We're gonna go to stat, we're gonna go to tests, and we're gonna scroll down here to the T interval in this case. So let's do T interval in this case. Double extra sure about that. Yeah, okay. So we're gonna do T interval here, and we're gonna have this list of here. We're gonna have data. Data is gonna be list 1, L1. Our frequency is gonna be 1, and we're gonna have our confidence level here be 0.98 to reflect a 98% confidence interval. Then we'll go ahead and go down to calculate, and let's see what we get. All right. So now we have our confidence interval. We have the lower bound here is 0.0794. And our upper interval 0.2292. Let's check that. All right, we got it. All right. All right, any questions about that so far, Heide? I will acknowledge this last part here for part C, but I just want to be sure that part B was clear about how you got that. Are you doing something with the critical value? Okay. Ah, okay. Yeah. All you needed to do was use the T interval thing for that. Like legit. Yeah, that's okay. That's why you asked me. I'm supposed to put you back on track. That's the idea. Don't worry about it. We all go through that. We all definitely go through that there. Let me check this here. What is that? 0.15. We can easily find the p-value for the two-tailed test. Okay, so the answer is no, definitely not. So does this sample evidence suggest that the calcium concentrates have changed since 1990? The answer is no, because the confidence interval contains 0.15 milligrams, which is what you're trying to compare. This does contain 0.15 grams, so unfortunately for us, that's going to be the answer to this question for part C. If it contains the original value in here, then you can basically say no for that question. Or you can check out the t-test that I put up here on the calculator. You see that the p-value here would be bigger than whatever level of significance you come up with in this case. So p-value here is like 0.87, which is pretty large. So not good for hypothesis testing, that's for sure. All right. So that is 10.3, number 6. All right. Next question here was 12.2, question 3. Let's do that one. To question 3. Come on. Alrighty. Okay, so let's go ahead and do this problem here together. That kind of partially covers up my stuff. Okay. Well, let's condense it down to something useful. All right. Okay, so a survey of 36 randomly selected students who dropped a course was conducted at a college. The following results were collected. Complete parts A through C. A, construct a contingency table for the two variables. So, yeah, no problem, Heidi. I'm always here to help. So first of all, we have to figure out how many male and females we have here for the course or personal and work. Okay, so This one here is kind of like a lot of manual counting, so unfortunately that's just how it's going to have to work out here. So let's take a good look here at the course. How many male courses do we have here? We have 1 male course, we have 2 male course, let's see here, 3 male course, 4 male course, 5 male course, 6, 7, 8, 9, 10. I think we have 10. 10 who are male and 10 who are underneath the course. Okay, that's fine. We can do the same thing for females. How many females in course? So, okay. 1 female for course, 2 female for course, 3 female for course. I gotta try that again, actually. I think I skipped one. Try that again. That's all good. 1 female for course, 2 female for course, 3 female for 1 female for course, 2 female for course, female for course, 4 female for course. So we get 4 here. All right. We have 4 female for course. Now we look at male and personal. So male and personal here. 1 male personal, 2 male personal, 2 male personal. See, nothing here. 3 male personal. Like I get 3 male personal. All right, we'll keep going here. Female personal, okay. 1 female personal, 2 female personal, 3 female personal, 4 female personal, up to 4, 5 female personal, 6 female personal, 7 female personal, 8 female personal, 9 female personal. Okay. And then we just go ahead and take a look at the list here for work. Okay, so male work here. So let's see here. Nope, not the first column. 1 male work. 2 male work. 3 male work, 4 male work, and 5 male work. Okay. And then finally female work. Let's go ahead and count that off. 1 female work, 2 female work, 3 female work, 4 female work, 5 female work, 5 female work. Okay. All right. So let's check our answer here. And we got it. Perfect. So that's basically for that one is just some busy work there, just kind of counting things up. That's fair. Okay, fine. All right. Test which gender is independent at the drop reason at the 0.1 level of significance. Okay, so this one here is basically taking a look here at, let's go ahead and take a look here at this particular section. I think if I'll start off, I want to say it's the first or second one here. So let's take a gander at that one. One I believe was this. That one I think is the second one. I have to remind myself of that one off the top of my head. Okay, so that one is indeed the second one, where they're both independent or dependent. So, right. So either the rows and columns are independent, or the rows and columns are dependent. So you got that right. All right, perfect. Okay. All right, Natty. So we're all the way through those first two parts there. Now we have to do the next part, which is calculate the test stat. Okay. Now we already have our test stat ready to go. Okay. So not test stat, sorry. We already have our contingency table ready to go. But we need to set up our test stat here. Now, how do we do that in this case? Well, we're going to need to go ahead and make up some matrices. If you remember, this was the matrice problem here that we had talked about from before. So we're going to need to use this matrix problem here in order to get this down. So let's go back to our calculator here. And we're going to need to enter in this contingency table you see here as a matrix in your calculator. So for us to do that, I'm going to go ahead and hit the second key. Go ahead and hit the x to the minus 1 key. I'm going to edit that first matrix there. Remember, this goes by rows and columns. So we're going to go and hit rows, which is 2 rows and 3 columns. We'll enter in all the numbers we see there. So these are the numbers that we got here from part A that we're going to enter in. This is our contingency table. Now, let's not forget we have 2 rows and 3 columns. Okay, so we're going to quit out of this, second in mode to quit. We'll hit second in matrix again. Remember that we're going to need to make up a matrix B here. And, oh, sorry, we need to edit that, my fault. There. We need to edit matrix B to be the same exact size. Man, can I not get some gas in my stomach? That'd be great. All right, we also want to make that the same size as the first matrix, a 2 by 3 matrix in this case. So we're going to go ahead and hit 1 here. And we'll put 1s here for all the entries in this matrix here in order to make it work for what we're going to be doing here next. Okay. And then we'll go ahead and quit out of that. So second and quit. There we go. Perfect so far. Alrighty. Next, what we're going to do here is to find our test stat and our p-value here. We're going to go ahead and hit the stat key here. We're going to go over to tests. And why do we put 1 for matrix B? This just makes sure that it's multiplying everything by 1, so it doesn't like mess up the matrix there when it's all zeros, basically. So it just that's all we're doing in that case. Like, we don't want to affect the matrix by anything, you know. So 1's just like make sure that everything has a number in it. We're gonna go ahead and put the chi-squared test, letter C here, Natty, okay? So the chi-squared test, or x-squared, whatever you want to call it here, we're going to use that guy here. We have the observed as our matrix A, which we've set up already. Our expected here is matrix B, which we've already set up as well. And then we just want to go down to calculate here and let it do its thing. So there we can see the test statistic at the very top. We round to 3 decimal places, 571 is what we get for the test stat. That's the first thing that you see there. And then we got that right. Now we did determine a p-value here. And the p-value, as we can see here, out to 3 decimal places is 0.062. 0.062. We'll check that answer as well. This is now, of course, your numbers are going to be different here, Natty, but you'll be working within the same vein that I'm doing here. Okay. And, hey, Connor. And let's make the proper conclusion here. All right, so what's our level of significance here? Hey, Athena, how's it going? Our proper conclusion is the 0.1 level of significance. So basically, at the end of the day, 0.06 is less than 0.1. All right, so then we are going to reject the null hypothesis and accept the null. How do I find the critical value of 94%? That's a good question. Give me just a second here, Athena. I can show you how. And then we'll check that answer, and that's correct. So that is the answer here to number 12.2, number 3. Hopefully that'll help you there, Natty, with that question. If you have any questions there, just let me know. Okay. So, where is it here? Critical value for 94%? Really? Did it give you that? No. Okay. Give me a second here. Thought I had this in the book. And it is there. This. Really? So I need to do... Okay. Let me go ahead and find that out for you. You kind of have to do this in the... Yeah, I know. No problem, Natty. I'm going to find this out manually then. Because it thought it would be in the book there. Yeah, it's no... Que no bueno. I totally agree with that. Do I know a good resource to learn discrete math? Not off the top of my head there, Sean. Not off the top of my head. Of course, you can use, oh, I know, buddy. Not off the top of my head, of course, Khan Academy is a really good resource for pretty much everything. So, I mean, I can always recommend that. I haven't done discrete math in a while, so that's why I can't really give you something more definitive. And to be fair, I haven't done it in a while. Okay, what was that again? I know, I'm sorry, bro. I don't mean to be a Debbie Downer in that regard, you know. Hey, Katie. Be 0.02. It is Tuesday in the UK, this is true. Actually, technically it'd be... Yeah, that's true, 0.02. Okay. Try this value here for try this value here, Athena. So I'm going to give you a value of which to use. Okay. Not just any Tuesday, though. Okay. Try 2.054 as the crit value. Question 7 on 9.1. I think that probably has stuff to do with, if I recall, that's the sample size question. I think that's right. Wait. Sorry. That's for 94%, right? Okay, I got it wrong. Sorry. I gave you the wrong number there. Hang on a second, Athena. I totally gave you the wrong number there. I'm so sorry. I thought it was 96% for some reason. Okay, it was 94%. Okay. Yeah, my bad. That's on me. All right, let's try this one here. 1.881. Try 1.881. That should be the critical value for 94%. All right. The stream, Katie, is going really well. We're all positives right now. All super positives. Natty says for C, would we divide F12 F21? That was for 12.3, I believe. That's what you're referring to. Which problem for 12.3 is that? Is that for Natty? I can show that off too. Oh wait, I'm sorry. There was a oops. My bad. There was a part C to that question that I completely missed. Oh yeah, I remember, bro. I'm so sorry. I just understood what I was doing. I'm like, that's a kind of a problem here. Okay. So what they want is they basically want a contingency. They want a conditional distribution here. So what they want here in this case is, notice that in the very first table here you have 14 people. Underneath the male you have 10 out of 14. So technically in this case what you want to do, actually, it's over. They want decimals here. We're just going to follow what they want. Yeah, so they want like 10 out of 14. They say, okay, well, what's that as a decimal? And you say, okay, well, that's 0.714. Okay. Females is 4 out of 14. So then you just do 4 out of 14. So you get point, I don't want to put 4 out of 14. 0.286. All right. Then we repeat this process here. 3 out of 12. 3 plus 9 is 12. So we get 3 out of 12 here. So 3 out of 12. All right, let me take a look at that there, Natty. 9 out of 12 is 0.75. Work is 5 and 5, so this would be a half. Check that. Did I have that wrong? Let me check that again. What did I do? Find the proportion for each reason, drop in the... Oh, whoops! I did the wrong way, sorry. I did it with the columns. My fault. I was supposed to do it by gender instead of doing it... Alright, that's on me. I did it through each category on the column, when instead they wanted it on the row per gender here. So how many do we have here? 10, 3, and 5. That's 18 males. So 10 out of 18 is what I should really have here, since they want it out of gender. So 0.556. Personal should be 3 out of 18. That's my fault, Natty. I'm sorry about that. Okay, 0.167. And then 5 out of 18. 0.278. Okay. Repeat this process with the females. 4 plus 9 is 13, plus 5 is 18 again. We'll take 4 out of 18 here first. 0.2222. We get 9 out of 18, that's a half. Strictly a half. And we get 5 out of 18. 0.278. Alright, the beans. Alright, let's check it now. And that's correct. Okay, good. Alright, we got that. And then, looks like she'll correct the bar graph here. Alright, so, let's see what we got here. I believe this is, yeah, so should be P should be the biggest one, and then should be surrounded by the other two. So it should be letter A. Yep. Alright, cool. Alright. What sample size should be within 4 percentage points with 94% confidence to be obtained? Okay. Yeah, so you need to use a formula with that, Athena. So I'm going to show off that formula here. So, alright, let me show that off here. What's up? So the formula that you have to use is the one that's listed up here. Okay? So the formula that you need to use here for, and I'll start with this, is basically what you see up here on the screen, Athena. I'm not sure if you're using this here, but I'll use your example here. So 94% confidence from the 52% obtained from a poll. And it has to be within 4 percentage points. So P times 1 minus P times the critical value divided by the margin of error. Okay? That's what we have here in this case. So in this instance, you need to take P, which is 0.52. Multiply that by 1 minus 0.52. Take the critical value here. Now, the critical value here, according to what we talked about here, is going to be 1.881. So we're going to put the 1.881 needs to go here. We'll divide that by the margin of error. Now remember, the margin of error in your problem is 4 percentage points, but you do have to reflect that as a decimal, and you're going to go ahead and square that. All right, I'm going to do that on the calculator, and we're going to see exactly what we get here. So we get 0.52 times 1 minus 0.52. Okay, and we'll multiply that by, go ahead and just do it manually, 1.881 divided by 0.04, and we're going to square that. So if we do that out specifically, we get 551.95 or 0.95, whatever. But again, we're just going to round up. No matter what, you're going to always round up, so it doesn't really matter. And so here we get 552. Yeah, if we got to square it, yeah, then that's going to be a problem. Yeah, you got to square it. So I got 552 for the first part there, for part A for your problem. Go ahead and give that a shot and see if it's correct. All right, so did you get the first part there, Athena? All right. Okay, bueno. All right, now let's take a look at the next part there. And the next part probably says, what if there's no estimate? Well, in that case, then in this case, you have to use the other formula, which is 0.25 times, again, the crit value divided by the margin of error, and you quantity square that. So it's just a repeat of exactly what you just did, only you just put 0.25 in instead in the front. That's all you pretty much have to do. So we're just going to have 0.25 times 1.881 divided by 0.04, and then of course quantity square that. Let's see what we get. Oh, I put double point. Square it. So here in this case we get 552.8. Nice. So yeah, round that up to 553. And it probably asks you one more question after that. It probably says, why are these so close? Is because you could say 52% is very close to 50%. So mark that button that says 52% is close to 50%. And then that's why they're so very close to each other in terms of the sample size. And that's the answer to that question. All right, and that should take care of that one. All right, all right. De nada. That I chill here. Okay, very good, Connor. Glad you get to sit and chill. Does anybody have any more questions? Hey, Take questions. There you go. Ah, there we go. Hide with another question. 11-2, question 1, part B. Okay, let's take a look at that. All right. Perfect, perfect. Exactly what I'm here to do, answer your questions. All right, I need to make my way over to 11-2. Okay. All right, so this was the matched pairs data question. So we'll just have to get through this first part here. So actually, I'm going to need the calculator for that, because we're going to do both parts on the calculator. Okay, so it says assume the differences are normally distributed. Complete parts A through D below. Okay, so here we're given some random observations with some random numbers. Let's go ahead and enter these into our list here at the very least. Let's do that right now. Hit the stat key, we'll go to edit. I need to make up some new lists, so let's do that here. List number 1 will be the X's, so then 44.6 is what I wanted. All right, so that's for the X's, and we'll have the Y's here. Those in. Okay, so there we go. We have the X and Y's in. Now, we're going to make a list number 3 here. Okay, very important, list number 3, because list number 3 is going to be X minus Y. So we're going to highlight list number 3. We're going to go on our calculator here. We're going to hit second and 1 for list 1, subtracted by second and 2 for list 2. That should populate list number 3, like so. So all these numbers here are the numbers that we're going to put in here for part. Okay. All right, so we checked all those. Those work out just fine. Okay, so now what it asks us to do is to find out what D is. Okay, so this is in your related to your question there, Heide. What is D bar and the standard deviation here? Fair enough, Connor. All right, so what do we do here in this particular case? Well, what we're going to do here specifically is we're going to take this L3 and do a nice little test with it. So let's take a gander here one more time. Where are we? Here. Okay. That's not. Wait, what? No. Okay, so what we're going to be doing here in this instance is we're going to be taking the t-test here. Had to be sure. So we're going to take second and mode. We're going to go ahead and hit the stat key here. We're going to go over to tests, and we're going to go down straight down to number 2 here, which is the t-test. We'll go ahead and hit enter here. Now in this instance, we are going to be given here a data, because we're using list number 3 as our data set. Now the first number that you need to put underneath here for data is going to be 0, because we don't know exactly what these numbers are just yet. Okay. We're going to go to list number 1, or list 3 here, excuse me. We do need list 3 here, because that's we're trying to find out the difference here between both of them. And we'll come back and come back to our tail test in case if come back to our test here once we take a look at it. So calculate that out. Now here we're given these two guys down here, so don't mind the test stat here in P. We're going to ignore that for right now, Heide. What we want here is these other two values here, which says X bar, which is our D bar actually, so it's going to be negative 1.6. And you see we got that. And our standard deviation is right below that, which is going to be 2.249. And that's correct. Okay, so we got that set and ready to go. Now, notice what it says here in this case. Now it gives us a condition of which to test over high day. So, yeah, the test didn't matter in the first part here, but now the test actually matters because now they actually give us something to work with. So in this case here, what's the correct null and alternative hypothesis? Well, we're going to assume that it's going to equal 0 as our null hypothesis, and it's less than 0 as our alternate. So we're going to come back and do this t-test again here, using these two guys as our null and alternate hypotheses. So what's our p-value here? Let's run the t-test again, and this time we'll change it to the type of test that was indicated here in this instance, which in this case is a left-tail test. So we'll change it to a left-tail test. Everything else should remain exactly the same. Go to calculate here. And as we see here, we have a p-value here of 0.042. All right, go ahead and hit enter on that. And that's correct. All right, and it says choose the correct conclusion here. Again, we're comparing it to the 0.05 level of significance. So because the p-value here is less than the level of significance of 0.05, then basically we're going to reject the null hypothesis. There's sufficient evidence that it's less than 0 at the 0.05 level of significance. That's correct. And there we go. We got it. Okay. Now before I move on to part D here, are there any questions so far? So before I move on to part D in this problem, are there any questions so far, Heide? Nope. Okay. So for part D here, it says to compute a 95% confidence interval for the population mean difference. Okay, all we're going to do here is we're going to go back to stat. We're going to go over to our tests. And this time here, we're going to go down to t-interval. And we're going to go ahead and put in data. We're going to use list number 3 here once again, frequency of 1. And our confidence level here is now 95%, according to the problem here. It wants a 95% confidence interval. We'll go to calculate. And there we go. We have our winner chicken dinner. So we have a negative 3.48 since it wants 2 decimal places, and 0.28. That's our upper bound here. And there we are. We got it. And that's going to be the answer for our problem here for 11.2, number 1. Oh.
1,002 log 10 to the power of 3.
Oh man, another Meiji man. Bro, another $6, dude. Thank you so much, Meiji man. Man, you don't have to do that. Dude, that's so super kind of you, man. That's so super kind of you. 1 to the 2 to the log of 10 to the power of 3. Very good. That is going to be 10 to the power of 3 with a log there is going to be 3. And because you have 2 times that, then you could technically say that's 6. I don't know what the 1 is there for, though. Unless it's just 1 straight up. Log to the 10 power of 3 is... That's technically 3. It's 3 times 2, which is 6. Made you mad. Thank you so much for the... It didn't send correctly in the message. Oh, that's why you picked $6. Okay. Thank you so much, Meiji man. I'm being an idiot. Thank you so very much, oh man. It's super kind here today, man. I don't deserve that. Thank you so much. Appreciate you, buddy. You're very kind. Holy moly. Thank you very much. Wowzers. I didn't expect to get donated to any. Actually, I don't expect any donations anytime, but Major Matt is making me look like a fool today, so can't really argue with you, buddy. Can't really argue with you, buddy. I still got the same coffee from this morning, so it's been a slow roll today. I'm getting this coffee down my system. I ain't gonna lie. Thank you for the hydrate. Appreciate it. Yes, we certainly can. Of course. 3 part B. Okay, let me move over to number 3. Yeah, we'll just check an answer there. All right, good. Okay. All right, so let's see here. We do part A. Okay, so researcher does this study here. Okay, so let's take a good look at what this says here. It says researcher studied water clarity in the same location during the course of a year. Repeats the measurements on the same dates 5 years later. Researcher immerses a weighted disc painted black and white and measures the depth in inches at which it is no longer visible. Collected data is given in the table below. So, there's the table there for the initial depth at each of these dates respectively, and we have the depth 5 years later. So there we have that there. Does the evidence suggest that the clarity of the lake is improving at the 0.05 level of significance? Note that the normal probability plot and black spot indicate that the differences are approximately normally. Okay. So, first and foremost here, we're going to make sure about part B here, which is we're going to make the assumption, you always make the same assumption, that the differences of the means between both guys is going to equal 0. Like if the clarity never changed, right? And then the alternate hypothesis here comes from the fact that, is the lake improving? All right, is the lake improving here? So that would mean that the difference here would have to be bigger than 0. If it's improving, then it should have a better depth than it was originally 5 years earlier. Oh, that's that not right. Let me see. What do we have here? I need to check the context here. Yeah, I know. This measures the depth in inches at which it is no longer visible. I think it's improving here. That would be less. Do the numbers indicate so my question is the lower the number? Is the lower the number? All right. Lower the number, the better the clarity. Is that what it's suggesting here? Maybe that's actually what's happening here. The lower the number, the better the clarity. All right. So I guess I could go with that. You put okay. All right. I guess the lower the number, the better the clarity. I guess we're gonna go with that. Fine. That's fair. All right. So we're gonna roll with that. Okay. Yeah, I can do question 1 on 8.2. That's not a problem, Athena. I mean, hey, if that's what they want, I'm just gonna roll with it, because I thought the better the clarity means that you could see it from further down. You'd have like a bigger depth, but I guess not? Question mark? Sure, why not? Okay, anyway, we'll just roll with the punches here. No, I agree with you, Hyde. Logic would dictate that, but hey, I'm gonna roll with this logic. I'm just gonna go with it. Sometimes I feel the same way as you do, okay? Believe me. I'm reading this carefully. I'm like, yeah. I'm like, okay, yeah, that makes sense. Like, no, that doesn't make any sense. Like, what you talking about, man? I don't get it. Okay, let's make up some new lists, though. Honestly, sometimes it's like that. It's so silly. All right. Okay. So they should really state that in the problem that the lower the score, the lower the depth, the more clear it would be. I don't know. You should probably state it. Anyway, it says to do x minus y here. So that's what we're going to do here again. Highlight list number 3. Do L1 minus L2. That they want us to do. Populate that list. All right. Now that we've populated list number 3, we're going to go ahead and do our test statistic here for the hypothesis test. Quit out to the main screen. Go ahead and hit the stat key here. Go over to tests. Go down to t-test here. That's going to be our guy. We have our data. We have 0. List 3 should be L3, so second and 3. Frequency 1. And we have a left tail test according to our backwards problem. And that's what we're going to run with. Go to calculate here and take a look at our test stat, which in this case is going to be 0.72. Alright, so that's what we get here for our test stat. That's correct. Our p-value right below is 0.748. Okay, so that one there directly gotten from doing the t-test. That's correct. And this has a level of significance that's probably 0.05. Yeah, definitely p is definitely not less than 0.05. So we're going to not reject. So do not reject the null hypothesis. There's not sufficient evidence. So we'll check that, and that's correct. So that's what we got for part B, is doing all that hypothesis testing. Okay, and then it asks for a box plot here, so let's take a look at a box plot. Draw the box plot of the difference to data. Okay, so what is our mean of our differences here? 0.88. Where is 0.88? Take a look carefully. This would not be it, so definitely not here. Our standard deviation here is 3. Take a look at our data just to be on the safe side. It's not A, that's for sure. It's not D, so it's between B or C. Let's check a look at. It could be B. I don't think it's C because that one looks like it's less than half for its mean. It's or that should be the median there, I guess I should say. Let's take a look at our data set here. It's our most extreme value, 5.3. Okay. My 5.3 is fine. It's our median. So 0.356. So do 1 bar stats on that. See what I get. Alright, so my median is directly 1. Okay, my median is actually 1. Alright, so right on the button. Alright, so it's not A, it's not D. Which one's on the button of 1? B is actually on the button of 1. Okay. So that's what this middle 9 represents as median. So B's got to be our answer for this. Okay. Does this visual evidence support the results obtained in part B? Yes, because the box plot supports I would say yes, it's not becoming more clear since most differences are negative. I would say probably, let's check A. Yep, A. So the answer is yes, it does say that. And most of them are around 0, which is why we cannot conclude that we can reject the null hypothesis here to begin with. So that's the last 2 parts there for number 11, number 11 2, number 3. 11 2, number 3 would be that. All right, good stuff. Any question? Nah, no problem. I'm here to help. All right, let me do. Athena says 8 2, number 1. All right, let's do that one next. Leave this question. 8 2. Alrighty, good stuff. All right, let me just restart here again. Just gonna get 9. Second. All right, I'm gonna start with a fresh question here. Yep. Okay. Okay, so I'm on part B. Okay, that's fine. So suppose a simple random sample of 50 is obtained from a population whose size is 30,000, whose population proportion with the specified characteristics is 0.6. Be parts A through C below. Okay. Describe the sampling distribution. It's approximately normal because n is less than 5% of the population size and p. Okay, so the answer here is B. You can check it out and find out for yourself there, but it'll work out. So we'll just move on. Okay, now determine the mean of the sampling distribution of p. The mean here is exactly what it's given to you at 0.6, so that's fine. And now the standard deviation. The standard deviation here is very important. The standard deviation here is going to be this guy. Let's go over the guy here really quick. The formula for this. So the formula here for the standard deviation is equivalent to p times 1 minus p. So the square root of that divided by n. So we're going to take the square root of p, which is 0.6, times 1 minus 0.6. Divide that by n, which is 50. So let's go ahead and measure that out on the calculator, see what we get. So I'll do 0.6 times 1 minus 0.6. I do this in steps, so divided by 50. Then I take the second and square root, and second and the negative key for the answer of that. You can do the previous answer. And so I get here 0.06, let's go ahead and put this in here, 0.06928, 069, oh, I put the wrong, all right, 06982. Okay, I put an extra number in there on accident. Okay, so we got that, perfect. Okay, let's move on to part B here. So part B says, what is the probability of obtaining 32 or more individuals with the characteristic? That is, what is the probability of p being bigger than or equal to 0.64? Okay, so in this case here, Athena, what you need to do is we're going to go back to an old friend, all right? And we're going to use the previous part here in part A to help ourselves out. We're going to go back to normal CDF in this case, because we're given here that p has to be bigger than 0.64. So we're going to go to second. We're going to hit second in vars. We're going to go to this screen here. We're going to go to normal CDF. Now, since we're dealing with proportions here, we're only dealing with things between 0 and 100%. So since this says p is bigger than 0.64, we're going to put 0.64 here as our lower. Our upper here would be 1 for 100%. So 64% to 100%. Then we're going to put our two values that we have here from part A. Our mean here, first of all, of 0.6. And our standard deviation, I'm just going to go ahead and copy that down right now, 0.069282. I'm just going to paste that in. And we'll see what we get here. In this case, we get 0.2819. is what we get here for part B. Let's check that, and that's correct. Any questions about that so far, Athena? We'll do part C here in just a second, but got it? Perfect. Okay, now, for letter C, it's a little different. It's a little different, but it says, what if the probability was less than or equal to 0.58? So we're going to go back to the well one more time. We're just going to enter in slightly different numbers here. So we're going to go back to normal CDF. This time, since we're less than or equal to 0.58, we're going to start at 0%. So our lower is 0, and our upper here is 0.58 as a result. We'll keep the other two numbers here exactly the same. Paste it in. Take a look at what we have here. And this is going to be our final answer here. 0.3864 will be our answer for this. And that's correct. All right. So we got that. And that's the end of question section 8.2, number 1. Hopefully that was pretty helpful. Hopefully that was helpful. You got no more questions till you finish this practice test, probably? Okay. That's okay, Athena. Remember, both of you have 6 more days of which to finish your respective tests, okay? So be sure that you finish up your 3rd test here that's due on the 9th. So be sure to work on those if you don't have any more questions for right now. Of course, I'll be here on Wednesday to certainly answer some more questions, but see if you can get that practice in before you actually try your real test. Of course, Heide, go ahead. Go ahead and ask away. Excellent. You know I'll be here, Natty. I'm not going anywhere. 9-1, question 3. Okay, let's take a look at that. Of course, I'm doing Q&As basically every class until the very end, Athena. So any questions that you have, I'm going to be taking it from you. All right, why? Okay, did I accidentally exit out? I think I accidentally did exit out. All right. Oop, I accidentally did that. I'm doing lots of bad things right now. That probably is not helpful for anyone. Give me a second here. I need to go back and redo a lot of things because I accidentally skipped that. So my fault on that. Let me get back to my math lab. For whatever reason, I accidentally hit the wrong button. All right. On my math lab, help me out here. Oh, you want me to sign in again after? Okay. Alrighty. Okay. Again, make sure, Athena, you start getting that practice test in. Remember, that's due by the end of the week, okay? So I want you to be sure you can catch up on your work appropriately, all right? Let's see here. That was 9-1, question 3. All right. All right. So let's take a look here at this question. All right, so this question here, no problem. So construct a confidence interval of the population proportion at the given level of confidence. So X is 120, N is 1100, and you're given at a 96% confidence level. Okay, so you're given basically in this first question, you're given saying, hey, what's the lower bound of the confidence interval? What's the upper bound of the confidence interval? All right, so Heidi, all you need to do here is let's bust out our calculator for this. It's actually more straightforward than you think. We're just gonna go to stat. I'm gonna go over to tests, and what we want here is we want number 5, which says one prop z test. Okay, so one prop z test is what we're going to be using here for this particular problem. And so we're going to go ahead and put in our oh, sorry, wrong one. Not one prop z test. I apologize. One prop z int. I am sorry. That should be letter A. I'm like, we're doing an interval, not an actual test. Okay. Yeah, so one prop z int. Sorry about that. I often get those confused. Okay. So we're gonna put in our x here. Our x here is the number of people who said yes to our whatever question. So that'll be 120. And here will be 1100. And our confidence level here will be 96%. Let's go ahead and calculate this out. All right, so we need 3 decimal places here, so 0.089, so that's going to be 0.090, because 89 bumps up to 90 with the 7 in the front there. So, all right. And then we'll have 0.128 for the other one, and that is correct. And there we go. We got it. And that's the answer to our question. Hopefully that helps. That's okay. That's why you're here. Hey, look, Heidi, that's why you ask me the questions. In case if you forget, I'm here as a good fallback option to help you give you a friendly reminder. So, no worries, okay? All right. Does anybody else have any other questions? It's been a good day today, actually. I've really been liking a lot of the questions. 9-1, number 5. Let's take a look at that guy too. Skip to number 5. Okay, so a survey conducted, a reputable marketing agency, 244 out of 1,000 adults, 19 years of age or over, confessed to bringing and using their cell phones to everything in the bathroom. Yeah. Texting and answering phone calls. Yeah. All right. What is the sample in this study? Let's take a look here. The sample of the study is adults 19 years or older. All right. So So the sample is going to be 1,000 adults 19 years of age and older. That's going to be part D. Determine the population of interest. Select the correct choice below. All right, so the population is all adults 19 or older. Population is blank adults. All adults with a cell phone. And we want to pick letter A. That's the population. Our sample is 1,000 of those people, but the population is everyone who's 19 plus. Okay. What is the variable of interest in this study? Is it qualitative or quantitative? So the variable of interest here is going to be the age of the respondent, no. The adults in the sample, no. Bringing one cell phone every trip to the bathroom. How many people bring their cell phone when they go to the bathroom? This variable is quantitative. Well, qualitative with 2 outcomes, okay. I guess we could say this. See if it's actually 2 outcomes with that. It is, okay. So qualitative with 2 outcomes, the reason is because you can either say yes or no to the question. You can either say, yes, I bring my phone to the bathroom, or no, I don't bring my phone to the bathroom. And then each individual is classified based on that yes or no response. Okay. Based on the results of the survey, obtain a point estimate here. All right, well, that point estimate here is fairly simple. That's 244 out of 1,000. So if we just do that on the good old calculator there, 244 out of 1,000, fairly straightforward. But again, just to kind of highlight this, 0.244, and that is correct for number for that. Explain why the point estimate is found to be a statistic. Explain why it's a random variable. Well, the source of variability. All right. Why is the point estimate found to be a statistic? Its value may change depending on the individual survey. It's used to make inferences. I mean, technically, kinda. It's a value based on a sample. Okay, I mean, it is. And that's the one we want to choose. It is based on a sample. Okay. So a sample here being 1,000, you can base it off of, X amount of people say yeah to my question, whatever. Why is the point estimate found to be a random variable? Its value may change depending on the individuals in the survey. This is true. All right. Again, we could ask 1,000 individuals and 244 may say it may not be 244 with a different set of 1,000 individuals. It could be 350 for all we know. So hence why the randomness in the random variable part. What is the source of variability in the random variable? The individuals selected to be in the study. So that part is definitely true. All right. Before we move to part E, I hope that parts A through D make a whole lot of sense there, Heide. Any questions about that so far, Heide? Okay, it does make sense. Perfect. You should be able to replicate that with your question as well. I'm going to take a wild guess here, and it's going to be the same set of questions pretty much, so shouldn't be any problem in that regard. Okay. Now, last part here is basically construct and interpret a 95% confidence interval. Well, let's go ahead and do what we just did here just a second ago. We'll hit the stat key. Go to tests. I'm going to go to 1 prop z int right here. Take 244 out of 1,000. Confidence level of 95%. Calculate it out. Okay, so we're going to pick letter B because it says we're blank percent confident. This is kind of what I wrote in the notes here, so same deal. We're 95% confident that the proportion of all adults 19 plus who bring their cell phone in the bathroom is between How many decimal places they want? Oh yeah, hang on. I'm just trying to see how many. Oh, here we go. 3 decimal places. Okay, so I need 3 decimal places here. So 0.217 and 0.271. Check that. And we got that right. Perfect. What ensures that the results of the study are representative of all adults 19 plus? Sampling? No? Let's see. A large sample size. That's right. I want to. Oh, no. Oh, they want. Oh, okay. I got that wrong. All right, I read that wrong. That's my fault. What ensures that the results of the study are representative? Oh yeah, it's random sampling. Okay, just put random sampling for that last one there. Ide. Sorry about that. I read that wrong. No problem. What do I put in the calculator for t-stat if there are 2 mean numbers in the problem? What number are you doing there, Natty? If you're doing like if you're doing the test stat, it depends which ones which one you're doing there, Natty. I don't know what section that you're on there. But if you're doing test stat, it should look like this. Or doing test stat, it should be t-test with the data and stuff like that. If you're doing the match pairs one, you have to make a 3rd list, Natty. That would be like in section 12, maybe 11.1. Yeah. 10.3. 10.4 is gonna be chi-squared, so it's not 10.4. 10.4 is with chi-squared. I know it's not that one. Okay, so where do I put the calculator t-stat? Are you sure that there are 2 mean numbers in the problem there, Natty? Could you send a screenshot on Discord? I want to see what that looks like. A screenshot of your problem. Okay, cool. Alright, let's take a look here. Alright, credit score. Alright, it's this one here. Yeah, that's right. Okay. Okay, so you're comparing that, right? Oh, whoa! Whoa, whoa, whoa. Alright. Time out. Alright, I see what's going on. I see what's going on here. I see what's going on. Alright. Let me post this up on screen here really quick. Alright, first of all, this number of 0.05 makes no sense, Natty. Alright, that is not what you should have here for your, that is not what you should have here for your null and alternate hypotheses. 0.05, your level of significance should never be in those spots. Alright? Never. I'm a sad face. Sad face. Alright? I'm crying right here with the coffee next to me. You know how it goes. If you put your level of significance in these spots, then the test will tell you, oh man, brah, what happened here? And that's exactly how I will say it. Alright, so, what should you have in those two spots? Well, you need to have the population mean here. And according to your question here, the population mean is 702.7. So that is what you need to have here and what you need to have here. Okay? You need to have 702.7 for that first one and 702.7 for that second one. He said, "Ah, hell no. That's a very good summarization of exactly what I've said in a bunch of words. I ain't gonna lie." Hell to the nah. So that's the first thing that we have to fix. We have to fix these two numbers here. 702.7 is what you want because you want the population mean there in that case. All right. Now we do want to identify the t-stat here. To be fair, this is the next part that we do have to do. Let's do that on the calculator. Man. Now, what do I do with you guys? What do I do with you? Man, shoot. Like I stepped into the Twilight Zone with that problem. Sheesh. What do I do? Just throw me? I ain't gonna throw you away. No, that's terrible. No, gosh, no. I'm not that bad. I'll never throw you away. No. I may be a jerk, but I ain't that big of a jerk. You know, I'm a mathematics professor. I have standards, okay? But it doesn't mean I've cast you aside because of reasons. That's not how it works. It doesn't work like that. Alright. Have that there. Let me take a look at that. Okay, no, I have to use that. Wait, why? Not what I want. Alright, look. Does that look like the one I wanted? For goodness sakes, but off. Let's do right. Alright. I need to use okay, I do. Alright, that's fine. Alright. Okay, so what we're gonna do is we're gonna use t-test here, only in this case here, Natty, we're gonna go ahead and go over to stats, okay? We're gonna go over to stats. And now we're going to enter in the data that we want in here for this particular problem, okay? Just need to go over to stats here. All right, so we're going to put 702.7, which is what we should have here. Let's see, what else? We have our mean here of our sample, which is 715.4 according to the problem. Our standard deviation, which is 80.8. Our sample size, which is 37. And we have a alternative hypothesis, which is going to be a right tail test. So that's going to be this guy right here. Okay? Does that make sense? All right. We'll go ahead and go to calculate. And now we can see our test stat at the very top here. So your test stat here is 2 decimal places, so 0.96 would be your test stat for that first part there. And your p-value, which is 3 decimal places, would be 0.173. Okay, so test stat 0.96. P-value here would be 0.173. Okay, you got that. You're half okay now. Good. Make a conclusion. Okay, in this case here, the p-value is definitely not less than 0.05. So you're going to do not reject the null hypothesis, right? So you want to say do not reject the null hypothesis. There is not sufficient evidence to claim that the mean credit score of high income individuals is bigger than 702.7. So at the end here, you want bigger than 702.7. You know, whatever the greater than wording is on the end there. And that is what you want to do for that problem. Just, Natty, don't make me sad. This first 2 parts here don't make me sad. You gotta make me so sad, oh man. No! Ah! I understand it. That happens with a lot of math questions. You tend to overthink everything. Totally understandable. All right. Hopefully that satisfies everyone here. I hope that will be just as good, or if not better. Answered a lot. Actually, I'll be honest with you guys. I answered a lot of questions here today. I'm really happy about that too. I'm happy that things are starting to ramp up here. And it was raining outside? Oh, I hadn't realized it was raining outside. So, shows you how much I've been. Hey, you know what? That's fine if there's a lot of questions today. That means that there's a lot to go over. That's why we have these Q&A sessions until the very end. Make sure you get this, get that in, you know? Very important. Hey, that's fine. I'm glad, you know. Ask as many questions as you want. That's important. Usually it's just me, fair enough. That's fair. Don't worry. You won't be don't worry. Wednesday, I'm sure we're going to have more people ask questions, so, just like today. So I'm pretty sure that the questions are coming in fast and furious due to the fact that we're heading to the end of the semester. So you can imagine we have 5 classes left. Count it, 5 classes left. So we are already at nearing the end. Yeah, it's getting to be that time. So, sorry we have to, you know, semester will be over. So, but hopefully it'll end on super positive vibes and super positive notes. Um, I'm not sure if you'll have another Twitch class again, but I hope that at least the first experience that you had with the Twitch class was at least a positive one. So, you've had a it's been a really interesting semester, that's for sure. All right. Okay, if there are no more questions here, no problem, Heidi. I'm always here to help. Always here to help. Yeah, you too. I hope you have a wonderful evening as well. I hope you have a very wonderful evening. I'll open the floor here. Are there any more questions anybody has? Otherwise, I guess I'll just have to end it off here for tonight, and we'll come back on Wednesday. All right. I think Daddy and Heidi are leaving, so I think, unless nobody has anything else to really add here, for today anyway, we will come back here on Wednesday, same time, same place, doing our darndest to do our best and review here for the final throws of this class here. In the meantime, please bring more questions with you. We got some more to do, certainly to cover together, just in case. Remember that the third exam is due on the 9th, so be sure to finish it by then. All right, everybody. Thank you so very much here for coming out and to the stream once again. All right, love you all. Thank you so very much. All right, have yourself a very wonderful, wonderful night. All right, take care of yourselves, and we will see you all on Wednesday. All right, take care, and remember, everybody, stay safe, stay healthy, and most importantly, stay sane. All right, take care, everybody. Have a wonderful night. Take care. Bye.